Hello everyone, here we have another question of a trigonometry where it is given that if a tan A is equal to n times tan B and sin A is equal to m times sin B, prove that cos square A is equal to m square minus 1 upon n square minus 1. So, shall we start it? So, here we are starting the solution. First of all, we can find the value of m and n by the given equations, this and this. So this will be tan A upon tan B equal to n, and sin A upon sin B equal to m, and we can put the value of m and n in this equation. Then this is LHS side over and this RHS side, so here we are taking RHS side, and the sin A upon sin B whole square minus 1 whole bracket upon tan A upon tan B whole square minus 1 and the whole square, then is equal to sin square A upon sin square B and minus 1 in denominator, tan square A upon tan square B minus 1. And now next steps, we can take the LCM over there, then it will be sin square A minus sin square B, denominator sin square B. Likewise we can take a LCM in denominator also, tan square A minus tan square B whole side tan square B. then this will इसको सिंपल कर बना लेते हैं इसको. सो साइन स्क्वायर ए माइनस साइन स्क्वायर बी अपॉन tan square A into tan square B multiplied by sin square B, and in numerator also this will be goes to the upward, then it will be tan square B. Okay, so now moving the next step, sin square A minus sin square B, and in denominator we can convert this into sin cos sin square A upon cos square A minus sin square B upon cos square B. Then inside the bracket, and this also will be converted into sin square B upon cos square B into 1 upon sin square B. So we are here, and this will be sin square B. Now for moving our next step, then we can cross out this to this sin square B and sin square B, and In numerator we have sine square a minus sine square b. In denominator this will be taken LCM and will be cross multiplied. Then this will be sine square a cos square b minus sine square b into cos square a, and in denominator cos square a into cos square b. Although we have this cos also, so we can write here cos square b. And next step will be sine square minus denominator we will have sine square a into cos square b minus denominator cos square a into cos square b, and into 1 upon cos square b, which is this one here. So it look like pretty good. And we are moving our next step. We can take this one is to upward, then it's look like sine square a माइनस साइन स्क्वायर बी, इसको ब्रैकेट में कर लेते हैं, एंड देयर विल बी cos square a into cos square b, and in denominator the bracket term will be there. Okay, and multiply with cos square b, then this cos square b is also cancelled with this, then we have this term we can write here sine square a minus sine square b upon sine square a into cos square b minus sine square b into cos square a, and multiply with cos square a. Okay, then our next step will be this now we can split this sine square b into 1 minus cos square b. Like that, and here is cos square. So now we are moving to our next page, so please wait. So we are here, I have write this on the top here. Okay, so I can proceed here from this, so we can move faster. Okay, then sine square a minus sine square b upon sine square a into cos square b, then my minus this cos square a multiply by this one, then it will be cos square a, this minus minus multiply will be plus sign here, and this multiply by this, then it's cos square a into cos square b, and the cos square a, this, and in the next step, and now denominator we can common this with these two terms. This is common, so we can simply take it out. Cos square b inside the bracket, sin square a here, and here is cos square a plus, and additional term this minus cos square is, you can write here and multiply by cos square a, and the value of this will be 1, and we can split this into 1 minus cos square a, and also this, and this will is 1, then the in denominator cos square b minus cos square a into cos square a, then 1 minus cos square a, this will be minus multiply minus 1 minus minus plus cos square b, and this plus 1 and minus 1 will cancel here also, and this denominator cos square b minus cos square a into cos square a, and next step we can write, as we see that this numerator and denominator equal, this term is writing here and this term is writing there. Now we can see pretty good, we are saying that this numerator and denominator is equal, so we can simply cross out, and we have left only this cos square a, which is our LHS term. We can see here cos square a, and we can have proved, you can see all this statement, and here also